Good morning. So if you haven't had a chance to do so yet, remember, if right now, let's go ahead and move around so that if you are a student and the first time you're being exposed to Deming or you're very new at it, sit next to somebody who has more experience. Bill, I see you're way ahead of the curve here. We're not picking on Bill today.
Yes.
Oh, there we go. Dennis, I knew it would work. Good morning, everyone. My name's Kevin Cahill. I'm the executive director of the W. Edwards Deming Institute and a grandson of Dr. Deming. The aim of this conference, as Dick Steele was talking about last night, is to learn, have fun, and introduce you to you or reinforce the teachings of the Deming philosophy through the lens and experiences of the leaders who are speaking over the next few days. Each of these speakers and many in the audience are going to distinctly remember where they were when they first came across or heard of the Deming philosophy. And over the years, hundreds and hundreds of people have shared those personal experiences with me, from students to educators, to entrepreneurs, to executives of large companies. And their stories are absolutely fascinating. A common thread is that the experience began a journey of learning, application, and exploration. The interesting thing is it always continues to this day. Think about that. It continues to this day. That's pretty powerful, and it's also very unique. I'm hopeful that some of the students and others in the audience who are being introduced to Deming for the first time this weekend will reach out to the Deming Institute and share their story, how this weekend was, quote, where they were when they first began this truly impactful journey. There is one story I've heard more than any other, and it is one that I share in common with quite a few people. It happened over a 2-hour period on the evening of June 24th, 1980, when I sat down with my grandfather, Dr. Deming, and my grandmother to watch a TV documentary on the NBC network titled If Japan Can, Why Can't We? How many in this room have seen that? Wow, that's pretty good. That evening, American leadership, as you all know, was in crisis. They were working hard and giving their best efforts to fend off Japanese companies whose products and goods were lower cost and higher quality than anything they could make. And as a result, many of them were losing market share. They did everything their common sense and business school background told them to do. It wasn't working. It was actually making things worse. As an example, Ford Motor Company in 1980 lost $1.6 billion, the second largest corporate loss in U.S. American history. As many of them sat down, many of those leaders sat down, they sat down to watch that program to see if it could provide some answers, and it did, changing their lives and our lives in ways we never could have imagined at the start of that program. What I want to do is kick off this conference and share with you a few clips from that program that focused on my grandfather, so you can experience what they did, what they saw that day on June 24th, 1980. So what I want you to do is to think about, put yourself into a position of where you're a leader of a company or you're about to start a business and you think you know a lot of the answers, or you're in a business where you're struggling. And so even if you're not, just imagine it and then think, okay, this is what I'm about to see, and take a look of what's going to transpire over the next 13 minutes. What I want to do is preface it for just a minute by saying, as you're watching the program, these leaders had no idea it was an American, Dr. Deming, that was responsible for that Japanese economic miracle. They had no idea. The program starts and you're going to see a flash of my grandfather for about 10 or 15 seconds, and they're going to talk for a minute. Then you're going to see the logo of Japan Can, I Can't, We come up. The next clip you see is 33 minutes in and lasts for a few more minutes. And I've talked to people who said, well, I saw this guy in the beginning, and then I didn't see him again. 33 minutes later, I see him for a little bit. I'm thinking, why are they not talking about him more? Then you're going to see the last 10 minutes of it, where they focused on him and Nashville Corporation. So that's kind of the layout, and we're going to go ahead and show that for you who have seen it before. It may have been many years, so it'll be kind of it'll be interesting refresher for you. So let's go ahead. Thank you very much, and look forward to a great conference.
What can we do to work smarter, not harder?
Japan needed to do this for survival.
Japan did it, we can do it. We make steel at a lower cost than any steel company in the world, including the Japanese.
It's not the American worker, as far as I can determine. That's a major part of the problem of productivity.
With 27 different agencies, each having their own little fiefdom, and promulgating dozens of rules a month.
The law of the land is such that it's illegal now for fish to go potty in the water.
This program is about the strongest, most productive economic force the world has ever known, the United States. We have been for a long time. There are reminders of that here in the Smithsonian's Museum of History and Technology. The question is not what we have been or are now, but what we will be. For the first time, our productivity is not increasing. Productivity is not some esoteric economic subject. It is how much we produce and how much it takes to produce it. The object is to make more for less. If you do, everyone benefits.
First of all, let me tell you that productivity game was taught us by Americans. We are very fortunate to have America as a good teacher, and we always try to be a very good student, and that's what made it possible for us to be somewhat competitive in the international market with U.S. industries.
The first time that I went there to teach industry, I taught 450 engineers in several cities, Tokyo, Nagoya, and Fukuoka.
W. Edwards Deming first went to Japan in 1950 to teach industrial productivity through statistical analysis. He was so successful that Japan's annual award for productivity is called the Deming Prize. It is one of the most coveted awards in Japan, and the medal that goes with the award is a profile of Dr. Deming, an American. The 1979 Deming Prize went to the Hiroshima plant of JSW, Japan Steel Works, which was so proud it had Deming's note of congratulation etched on a block of stone outside the plant headquarters. 2,000 men and women work at that plant, and JSW provides recreational facilities for them to use when they're off. That is standard with major plants, even in crowded industrial areas. When the game is over, work resumes making industrial machines and devices, including huge ball valves for pipelines. The quality of the work is so high that there are only 6 people in the plant's quality control department. The production workers build in quality and make an average 10 suggestions per worker each year on how to do it even better. Reliability, the one word that tells it all. That's the motto of Fujitsu. The company makes computers and telecommunications equipment, and the workers are organized into quality control groups, QC circles, as they are throughout Japanese industry. The Japanese believe in consensus, with workers and managers participating in and agreeing on the best course. In that way, when a decision is made, everyone supports it. Visiting Americans always want to see a QC circle meeting. Traditionally in the United States, there is little participation and no consensus. Top management issues orders, everyone else takes orders.
In almost all the solutions to the problem of productivity, there is a common thread. Each of them includes, in some way, worker participation or job security or both. Every expert to whom we talked agreed that no solution can succeed fully unless it includes the active participation of the people who actually do the work, union or non-union. All humans think, and nowhere is it chiseled in stone that those in management think best. We have said several times that much of what the Japanese are doing, we taught them to do. And the man who did most of the teaching is W. Edwards Deming, statistical analyst, for whom Japan's highest industrial award for quality productivity is named. But in his own country, he is not widely recognized. That may be changing. Dr. Deming is working with Nashua Corporation, one of the Fortune 500, a company with sales last year of more than $600 million. Deming was hired in late 1979 by Nashua's chief executive, William E. Conway.
I would say that already we're saving millions of dollars. Well, we'd probably improve the overall productivity of the company, something in a few years by 10 to 15%, and that every year thereafter you'd take and get incremental increases in productivity of 4 or 5%. Now, I mean that over and above that which you'd get by normal capital investments or normal changes in machinery and things like that.
Nashua started in New Hampshire in 1904 as a small paper converting company, and coated paper, like this carbonless paper, is still a substantial part of its business. Nashua also makes computer memory disks and other office products, including, starting this year, its own office copying machines. It had worked with a Japanese copy maker, and through that relationship heard about Deming. The company sought him out.
We've applied the Dr. Deming statistical technique to our carbonless coating operation. Once the process was under control, we were able to save up to $500,000 by reducing the coat weight and also maintaining consistent customer quality. And what this also has done is allowed us to free up personnel, make them more available for testing in other areas, which we found to be very important. The statistical approach has allowed us to learn more about the system. Before the use of Dr. Deming's techniques, we were constantly changing the conditions on the coater.
The coater is crucial to the carbonless paper business, so Deming insisted that the machine be allowed to run by itself, then analyzed what the machine would do without human adjustments. It was more complicated than that, but based on the quality level Nashua's customers asked for and the machine's performance on its own, Nashua could change its operation, meet all quality needs, and save money.
After applying these techniques, we're able now to sit back, let the coater operate on its own and make less adjustments to the machine.
If you get gains in productivity only because people work smarter and not harder, that is total profit. And it multiplies several times.
Dr. Deming, who is now 79, and his wife have lived for some years in this house in Washington. His office is in the basement, and Mrs. Deming is one of his assistants. He works constantly and has absolute faith that his system of statistical analysis helps industry. He was equally certain of it when he went to Japan to teach it there.
I think that I was the only man in 1950 that believed that the Japanese could invade the markets of the world and would within 4 years.
If the Japanese were impressed with Deming and his system of quality production through statistical analysis, and they were no more impressed with Deming than he was with them.
What I saw was a magnificent workforce, unsurpassed management, and the best statistical ability in the world. It seemed to me that those three forces could be put together, and I put them together so that Japanese quality, instead of being shoddy, became known within a few years. In less than 4 years, manufacturers all over the world were screaming for protection.
And of course, our major supplier of copy machines was a Japanese company. And so we saw the advantages of many things that Japanese companies were doing, and we'd heard about Dr. Deming, so we got off and got underway with a quality program with Dr. Deming.
They realized that the gains that you get by statistical methods are gains that you get without new machinery, without new people. Anybody can produce quality if he lowers his production rate. That is not what I'm talking about. Statistical thinking and statistical methods are to Japanese production workers, foremen, and all the way through the company, a second language.
And what we need is to have Dr. Deming help us learn what the Japanese so successfully have learned.
As part of his program, Dr. Deming teaches practical statistics so that everyone in the plant becomes part of the quality control effort, understanding what has to be done and how to go about doing it. Everyone can participate, everyone gets a say. It encourages company loyalty.
Japan needed to do this for survival, and they did it, and they've done it well. Now we've got to try and learn the things that they've so successfully done.
Japan did it, we can do it.
In statistical control, you have a reproducible product hour after hour, day after day, and see how comforting that is to management. They now know what they can produce. They know what their costs are going to be.
Many of these programs on statistics have died in American companies because they didn't get the top management support. Now, why top management does not believe that this is the way the Japanese have improved their industry over the last 30 years, I don't know.
I think that people here expect miracles. American management thinks that they can just copy from Japan, but they don't know what to copy.
It probably, for the first 6 months, I would say, of the program, I spent half my time, at least half of my time, talking to people, thinking about it, writing memos, joining groups, so they can try to convince them of the importance of this tool and how to use it.
The training that the Japanese workers have could be copied here and is being copied some places, but there's not enough of it.
And even today, probably the top 100, 200 managers in the company are devoting 25 or 30% of their time to nothing but furthering the quality program.
If that sounds like a lot of time and effort, it is. But Dr. Deming never said his system was simple. He only said it would work and it would pay off. In the experience of Nashua so far, it pays off.
Since Monday, the loading and unloading has been much better because Morris, the mechanic.
The Deming system uses statistics to eliminate guesswork. Statistics is not magic, nor is it a science. It is a method of finding out exactly what is happening and what is likely to happen. Once you know that, any competent management can fix what's wrong.
Mesh now, or there's some specific mandrels?
Well, there's one that could use a little, number 2 mandrel could use just a little bit of attention, but other than that, they're pretty good. We have begged for deeper grooves in the trays. They're not deep enough, they don't really grip.
The idea is to establish first what a product should be or a process should do. From then on, if you leave it alone, it is always the same. But the Deming method involves constant monitoring of the system, particularly by the people who do the work. The program to do it better, faster, and easier never stops.
It could be causing aluminum chips in the coating room. So anything like that, be sure you let George know or somebody know.
And once we started to have some success stories, we started to use the people who made the successful programs, talk to other people in small groups and gradually larger groups.
By dropping the handling damage down from 12% to approximately 5%, we are presently saving $30,000 a month. And as our volumes grow in the next 3 or 4 months, we should double that to $60,000 in cost savings a month.
That's $720,000 a year in one area, enough to please any management. But one part of Deming's program is not likely to please them. He insists that management causes 85% of all the problems.
I ask people in management what proportion of this problem arises from your production workers, and the answer is all of it. That's absolutely wrong.
Well, as we got into it,
Dr. Deming was right. 85% of the problems were really management problems. It was part of the system, whether it be training, morale, mechanical type things. There weren't that many operators out there that just didn't care.
Inspection does not build the quality. The quality is already made before you inspect it. It's far better to make it right in the first place. Statistical methods help you to make it right in the first place so that you don't need to test it. Correct. You don't get ahead by making product and then separating the good from the bad, because it's wasteful. It wastes time of men who are paid wages. It wastes time of machines, if there are machines. It wastes material.
The first thing that we did was to have some posters drawn up to emphasize handling the image, how it was caused, and how we could eliminate it. People just didn't understand how delicate a disc is, that by scratching your fingernail across it, you indeed ruined it so that it couldn't be used again. They went out, our original group grew from 8 to about 15, and it was a lot of peer pressure. You know, they got out on the floor and said, oh, by the way, you're not supposed to be wearing rings while you're handling the discs. You know, that could cause a problem, and explain.
There's just no question, in my mind, that Dr. Deming is the father of the third wave of the Industrial Revolution. Remember the first wave way back with Eli Whitney and the cotton gin and the development of the textile industry in England. And the second wave being in the United States, the large homogeneous market, followed up with low unit costs from mass manufacturing with standardization of parts. Now this changed to the use of statistics to assist all phases of production, marketing, distribution, what have you, that Dr. Deming talked about, is just as big as either one of those. And anyone who doesn't join that revolution, I think, over time is going to be in serious trouble.
Nobody comes out of the school of business that knows what management is or what its deficiencies are. No one coming out of a school of business that ever heard of the answers that I'm giving to your questions, or probably even thought of the questions.
Sounds a little harsh, Doctor.
Yes, I am harsh. I should know what I'm talking about.
Is there an attitudinal difference between the United States and Japan?
They are using statistical methods. They have not only learned them, they have absorbed them. As Japanese absorb other good things of cultures. They are giving back to the world the products of statistical control of quality in a form that the world never saw before.
Would the same methods work in the United States? Could we do the same thing?
Well, of course we could. Everybody knows that we can do it.
Why don't we?
No determination to do it. We have no idea what the right thing to do. Have no goal.
Americans have always believed that wealth is not limited, that the economic pie always expands, and if you want more, you can get it without taking it from anyone else. Other people, British and Swedes, for example, have come to believe that the economic pie is one size, and the only way to have a bigger share is for someone else to have a smaller share. The trouble is that those without want to get more, and those with want to give less, and each side resents the other. That can make for very serious conflict. The American belief of ever-expanding wealth avoids that conflict, but it works only while productivity increases, what Dr. Deming calls working smarter, not harder. Productivity is society's dividend, the payoff for all our work. Increasing productivity pays for fighting society's ills without having to take money away from something else. So what is happening to our productivity now comes at a particularly bad time. As we recognize more human needs and try to meet them, our economy is suffering inflation and recession. The United States has overcome inflation and recession before, but it has never even faced a productivity problem. Manufacturing, making things, is a smaller percentage of our national economy than of any other industrial country, and that makes productivity improvement even more difficult. Until now, probably because the United States was such an enormous and expanding market, productivity has almost automatically increased. So throughout our history, Parents have expected their children to live better than they did, and that has always been true. We live better than did our parents, and they lived better than their parents. Unless we solve the problem of productivity, our children will be the first generation in the history of the United States to live worse than their parents. I'm Lloyd Dobbins, NBC News.
Some interesting things that I think still touch on some of the problems today. So I hope you enjoyed that, had an opportunity. If you have an opportunity to watch that again or are interested, please contact us at the Deming Institute. We're working with NBC Universal right now to make it more widely available than it currently is. So hopefully you'll have a chance to see it again. We're going to move on in the program, but the one, yes, Pat? What's that? My experience, she asked what was my experience that day. I'll briefly tell that story. Like we were talking about, where were you when you first heard Deming? A lot of people say, well, because I grew up with him and spent a lot of time with him, I heard about Deming all through my early life. That was not the case. We knew him as a grandfather, very kindly, gentle grandfather. And it wasn't until 1980 when my family had moved to California and I came back and stayed with my grandfather that summer that my mother, who's sitting in the back, called me and said, your grandfather is going to be mentioned on a program about some of his work. I thought, yeah, that's really cool. You know, your grandfather's going to be mentioned in prime time television, and have him watch it with you. So we sat down together to watch it. And by the way, he was not really interested. He had a lot of work to do. He worked out of his basement, like they said. He wasn't really interested in going and watching some television program. So that's what happened. You saw in the beginning, they had that one little clip of him. Well, that's pretty exciting as a 20-year-old. Oh, I saw my grandfather on TV. Then they don't talk about him. Till 33 minutes later, when you saw that gentleman standing up in front saying the Americans were the ones that taught us. So for the first time since we started watching the program, I opened my big mouth, turned to my grandfather and said, do you know any of those Americans? And then the next part, the announcer says, and his name was Dr. W. Edwards Deming. And I still get chills to this day because it's kind of that out-of-body experience of, that was you? I mean, I'm 20 years, how did I not know that you had been doing this and had that impact on the Japanese? Had no idea. It was stunning to me. And then immediately they went away after about 2 minutes, as you could see. And then it wasn't until we sat there for another 45 minutes and I thought, I'm not going to open my mouth anymore. And then they came back at the end of the show and you saw the last part of it. So it was a pretty stunning night. And then the rest of that summer was pretty amazing because my grandfather worked out of his basement, had a speakerphone, and was very hard of hearing. So it worked to my grandmother and my great aunt's advantage. We would stand at the top of the stairs and quietly open the door to the basement, and we would hear him talking on the speakerphone as the titans of American industry called in and asked him for his help. So I think one of the things that I'll leave with is that struck me was, I thought, this is really sad because he's 79, he's just being discovered, and there's not much time for him to do anything and to learn more than what he's already done. And he was always talked about learning was key for him. From 79 till he passed away in 1993, he worked virtually every single day to make a difference and to help and to learn and to provide that learning for others. And I think that was really, really important. He died, passed away. It was a little bit 2 weeks after his last 4-day seminar at the age of 93. So he was driven, really wanted to make a difference. And what you're going to see next is going to be fascinating because you heard all this focus on statistical process and how important that is, and that was my grandfather's background. But he never stopped learning, and he took it to the next level and continued to say, how can I improve management? You heard that point where he said 85% of management, the problems come from management, not the worker. Bill Bellows mentioned that last night to a degree where he said, get my grandfather's book, because at some point, you're going to get into a job and you're going to be that worker to begin with, And you're going to be frustrated. And if you start to read that book and come back to this, you'll get that feeling on what is the problem with management. Eric's going to talk about that and where my grandfather took his philosophy to even be more robust, more powerful than it was in 1979 and 80 when that program aired. So thank you very much. Thank you, Pat, for mentioning that. And what I'm going to do right now is introduce the illustrious Dave Sly. Dave Sly is a professor of practice and director of professional graduate programs in the Industrial and Manufacturing Systems Engineering at ISU. Whew, that's a lot. Where he received his BS, MS, and PhD degrees in IE, as well as an MBA in Marketing and Professional Engineering license. In this capacity, he's been actively involved in the department's sponsorship of the Deming Conference, both this year and in the past. So we have a lot to thank Dave for the students who are here. Dave is also president and founder of ProPlanner, which is an internet-enabled industrial engineering software firm located in the ISU Research Park. ProPlanner is an extension of a company that he started as an undergrad in 1984 and subsequently sold to an organization now known as Siemens PLM in 1997. Through his previous two companies, Dave Sly has sold over $50 million in engineering software and services to over 900 companies in 39 countries, including some of the ones that we're seeing in this program, and Ford, Chrysler, General Motors, Case New Holland, Deere, Caterpillar, Polaris, Mercury Marine, Nissan, Honda, Toyota, and then some really cool ones. SpaceX, you ever heard of them? And Tesla. Let me join us welcoming Dave to this podium. Thanks.
Well, welcome to Iowa State. I'd like to echo what Dr. Gary Merka said last night. We're very proud to be hosting this conference on behalf of Iowa State, on behalf of the College of Engineering, which Dr. Merka is Associate Dean of, and of course, the Industrial and Manufacturing Systems Engineering Department, where I'm at here today. We're very proud of our campus. We're very proud of our facilities. We hope you get an opportunity to come around and literally walk around and check things out. It actually isn't raining today, so those of you from Seattle may actually get a chance to see the sun, and this could be a great opportunity. Iowa State's been in quite a period of growth. It's a very exciting place to be. We just passed 36,001 students. Interesting, I don't know who the one was, but we just passed 36, which is quite a bit of growth for us. We're now the largest university in the state of Iowa. That wasn't always true, but it is now. And there are other Iowa shirts that you can buy, I might add, but make sure that the word after Iowa says state, and you'll be in the right clothing attire for the weekend. We are now, I heard we were top 10, actually just found out today from Paul Jewell that we're maybe 6th largest engineering college in the United States. Our Industrial and Manufacturing Systems Department is actually in the top 5. We may be 3 or 4 after this semester with almost 600 students. In fact, my role here today is to really help foster and facilitate the student engagement of the Deming philosophies. I'd like to have the undergraduate students who are here stand up, please. You could? So, great. And I would like everybody to kind of keep an eye out for these people, all right? And please interact with them, share your thoughts. Students, the people who aren't standing, those are the people that you really want to be also sitting next to and interacting with as opposed to clusters. You can sit down now. Thank you very much. And then the undergrads, if you could, or sorry, graduate students, if you could stand here. I know we have a number of graduate students. Excellent. Great to see a great group of graduate students. This is awesome. Thank you down there. So once again, look at the other people around to mingle with and to learn from. This is a great opportunity. We have over 50 students registered for this conference now from Iowa State. Dick Steele, Dick, are you here? No, there he is back there. Was very instrumental in helping with the sponsorships and scholarships. So please thank Dick. And I think there were some others as well. Jack Hiller, is he here today? Yes. Hey, Jack, thank you very much. So students, Dick Steele, Jack Hiller, please thank them. So I think that you guys the students here made a great decision. I really hope that you get engaged and really learn about Deming's principles. This means a lot to me for a number of reasons. I also had an opportunity when I was your age to attend a conference and a meeting with another gentleman who is profound in the field of industrial engineering, and that's Richard Muther, who is well regarded as the father of factory layout and design, who also had very experiential life-changing moments in the World War II construction of the military industrial complex in the United States, as well as assisting with some reconstruction efforts of production over in Asia, who unfortunately passed away last year. The point about these people that I think is really amazing isn't just, which by the way is huge, the technical methodological practices that they contributed to our field. And when I say our field, industrial engineering, that's a pretty broad statement, right? I mean, these practices are used in all kinds of domains and disciplines, but they are core concepts in industrial engineering. The Deming techniques, which there are many different ones we'll learn about here in this program, as well as the techniques we've learned from Franklin Lilliath Gilbreth or from Muther and others, are foundation principles, right? I mean, that's what we go into industry with. The Short charts, you know, that Dr. Deming worked with Short, they're the foundation techniques that we start with when we do every project. And as engineers, we like our formulas, don't we? And as engineering professors, we like our tests to be all about this math problem and that math problem. Here's the thing that I learned the most in being an understudy of someone who is transformational. And you're going to see this with the Deming videos, especially that you see here today, it isn't about the formula. Principally, it's foundation. But unless you get the people engaged, unless you change behaviors, okay, unless you create a cultural transformation, you will accomplish nothing. Unless you get the people on the floor engaged and involved in using the techniques and tools. Not hog them to yourself, not be in this little white pillar and this white tower and be the keeper of the secret formula on how to understand whether we have a problem here or a problem there, or how to solve it. But to be a change agent, to be someone who can take these concepts and break them into methods of communication, okay? Where you can, you know, the Muther always said to me, when we do these material flow diagrams, right? We track material flow through the facility. We have colors and thicknesses and arrowheads and all. It's not about the number at the end. It's about the picture and how its ability to get 30 people in a room to collaborate and come up with the final design, the best design in the shortest possible time with 100% agreement that this is the way we need to move, and they walk out of that room and they do it. And I see so much of that as I've learned about Deming and seen more about his principles. Once again, it isn't just the chart. The chart by itself is nothing without the people understanding the chart, participating in the chart, using the chart as a change agent, as a communication tool for the group to come together and to make things happen. So as students, right, who we've now programmed in your head for 4 or 5 years that it's all about the formula because every test and every exam and every homework problem is all about the formula, it isn't all about the formula. It may start with the formula, it may start with the chart, but it's about your ability to interact with people, to be a change agent, to communicate. I mean, really, it's the workers and the management that need to come together in the solution. You just need to be the person to facilitate that process. So I really want you to spend some time looking at that. As professor of practice here in the Industrial Engineering Department, many of you know, the students at least know, that my job is senior design capstone. My job is to put you out in the field and help you be successful. Some of you know that have had the class, and those of you who don't, you're going to see this. The process by which we do that is we give you a direction. You go out with your parent company. You go and work with them on understanding the problem. Your current state analysis does a technical, analytical evaluation of the problem to confirm that it exists and exists in the way the client thinks so, right? We then move into future state design, where you create multiple alternatives on how the problem could be solved, all along working with the people on the floor, right? All along working with the managers. Once again, the most important part of that is interacting with the people. But I also want to stress with those of us in here that are in education, if you've been to Capstone, that we meet together, myself and the students, each group, 3 times a week, reviewing what you're doing, where you're presenting your ideas and I'm providing you the feedback, so that you have basically not just one graded assignment or one evaluation from me, but before you even turn the assignment in, we've already gone through 5 or 6 or 10, or some of you even many more than that, right? Iterations of that design. And I want you to really take that home, because getting something right the first time versus getting something right and doing it in an interactive dialogue is really what it's all about in terms of learning. And the reason we do this isn't just for your evaluation, but to hopefully impart upon you some of the things I've learned here at the Deming Conference that have changed my behavior and how I run Capstone, is to how you can apply those concepts to the people that you work with in the field, instead of these single condescending assessments that you get a D or you get a C because you didn't meet these requirements. The only way anyone should not perform well is because you've given them every opportunity to perform well, and they've chosen not to perform well. So last comment or parting comment on that, please, like I said, take the concepts that you're going to learn here today to heart, and deploy them, use them, be a change agent. But think about how you, as an engineer, can take even other new concepts that you learn or know and be a change agent for your organizations moving on. And if you're an undergrad and you're working in a facility, or even if you're a grad student developing software, right? Everything that you do, whether it's software or a machine or a business process or a manufacturing process, is a manifestation of a way to do something, right? It's a workflow, it's a business practice, not just the machine that actually makes the part, but how it's being used and how it's changed or maintained. Think about that. Think about the whole process, not just the machine itself. And hopefully, like I said, you'll see where Deming was just so good at communicating ideas and getting people engaged and involved so that they understand what to do and do right.